Back at it again. Okay, so last video I did was a power to a power, multiply the powers. Now what we are going to do is another power rule. Oh, don't really know what happened there, but it looks like it kind of, sort of, maybe, probably didn't work. Go away. You know what? Let's just do this. There we go. Okay, y'all. So another power rule is, say in parentheses, you have multiple bases. In this general example, it shows us two bases, A and B. All this is saying is that they're different. We don't have two A's, which would imply they're the exact same. We have an A and a B. It's telling me it's different. Just so you know, you could have A, B, C, D, E, F, G. You could literally have 4, 5, 6, 7 different bases inside of a set of parentheses. And on the outside of your parentheses, it be raised to a power. It does not matter how many bases or different variables you have inside of your parentheses. This power states that this power rule states that each individual base inside of your parentheses will be raised to the power on the outside of your parentheses. So if you have in parentheses A, B raised to the M, what you do is your A gets raised to the M and your B gets raised to the M. Just remember, if you have A, B, C, D, E, y'all, what I'm saying is if you have the exponents, let's say, I don't know, I guess X, Y, and Z raised to the 5. Now you have X to the 5th, Y to the 5th, Z to the 5th. Everything gets raised to that power, okay? There is one very special stipulation or rule that's going to go with this power rule. I'm going to write it in red because this is very important. This does not apply to the sum of terms. If you notice that A and B inside of the parentheses, those are being multiplied, right? They're touching. That means they're multiplying each other. That's when you can apply this rule. If you have in parentheses, say you have A plus B raised to the M, this product rule does not apply to the fact that there is a sum, because those two different variables, those two different bases are being added inside of parentheses. It does not equal both of them getting raised to that power. Be very careful with that. Okay, they will try to trick you. I guarantee it. So let me do an example. So let's say that we have something like 4x raised to the third power. So 4, that's a base, it's a coefficient, but it's still just a base, it's a term, right? And then we have our x, which is also, that's different than our 4. Our m here, y'all, is a 3. So it's saying that in parentheses, my 4x is being raised to the third power. Follow that rule. Do you see how the 4 is acting like your A? And I know that it's going to get the power as well as my other term getting the power. If it asked you to evaluate it for exponents less than 4, you would actually go ahead and evaluate this. And sometimes it will be specific. If you've got an exponent of 12, it doesn't want you to actually evaluate that. So if we do 4 cubed in our calculator, we would get 64, and then our x cubed. It would be x cubed. If it says leave an exponential form, then that would be that answer right there, okay? Okay, so let me do this one. Say we have, Allie, stop. Say we have, come in. Allie, stop. Say we have, sorry, someone was at my door. Say we have 3xy all being raised to the second power. following the power rule, which states that if you have multiple bases inside of parentheses, all being raised to a power, each base inside of your parentheses will be raised to that power. So what you would do here is you would individually break apart every term inside of your parentheses, raising each of them to the power that's on the outside of your parentheses. So because my 3xy is being squared or raised to the second power, what you do is you raise your 3 to the second power, you raise your x to the second power, and you raise your y to the second power. If it asks you to leave it in exponential form, 3 squared x squared y squared would be your answer. If it asks you to actually evaluate, what you would end up having is if you do 3 squared, you get 9. So it would be 9x squared y squared. Okay, I have one more example for this power rule. Okay, I'm going to need more room though, because it's actually going to be a little bit of work here. Okay, so say we have in parentheses 2m squared p cubed, close that parenthesis, raise it to the fourth power. I'm doing this one because it's actually going to combine some rules that we have looked at. We're going to do more combination of rules at the end of all of these 12.1 videos, but I think that this is a good video to just kind of go ahead and introduce that. I know that I just learned the power rule that states if you have multiple rules inside of the parenthesis being raised to a power, everything individually gets raised to that power. So what I'm going to do is first apply that rule. But y'all need to pay attention to the fact that that's an m squared and that's a p cubed. So those are going to need to be dealt with specifically. Let's do it right here. So that first term that I have is a 2. That gets raised to the fourth power. And then right here, that's an m squared. When you raise this to the fourth power, put it in parentheses. If I can not mess up my pen. Okay, so do m squared in parentheses and then raise it to the fourth power. Do you see how this is a power to a power, multiply your powers rule? Let's do the same thing with our p cubed. In parentheses, you'd put p cubed and then you raise everything to the fourth power. So I'm going to go down right here, y'all. So evaluating this, if you do 2 to the fourth power, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 would be 16. And then our m squared and then raised to the fourth would be power to a power. I know I multiply my powers. 2 times 4 is 8. And then for my p cube and then raised to the fourth power, I get power to a power, multiply your powers. You keep your variable or your base and you multiply 3 times 4, which would give you 12. So that would be your final answer right there. Okay, y'all, so make sure you ask if you have any questions. I will record the other power rule, the combination of rules, and applying these rules to a geometric application next. Okay, thanks. Bye, bye, bye.